problems lettered R, T, and U are definitely a little bit different from an area standpoint because they have an absolute value. And while I don't want that to be confusing, I do want to take the opportunity right now to talk about the effect of an absolute value, because I think it's going to be important going forward to just understand how basic little innocuous operations like that can actually affect our geometric thinking, and hopefully in an easy way to understand. Absolute values are actually much harder to deal with algebraically because they involve breaking things up piecewise and stuff like that, and you'll see that in the next video. But for now, let's think about what an absolute value would do to an actual area. Now in letter R, we're talking about the area from 0 to 10. Now you'll also notice, if you're looking at my paper here, I've taken the liberty of filling in a few extra details that you also might have on your paper at this point. I purposely filled in my answer to letter J because I noticed that the integral from 0 to 10 appears in letter J, and it appears here in letter R as well. You'll also notice I took the opportunity to kind of color code and break down all the individual areas of all the individual regions, and I'm just going to refer to those as needed. Now in letter R, I'm not sure if I need to go back and do the entire problem again. What I want to think about is the fact that the absolute value is surrounding the integral itself. And by substitution, I'm thinking I can do something kind of clever here. I already know that the integral from 0 to 10 of f of t dt, that entire expression, is equivalent to 2.5 plus 2 pi. So I can take that expression and by substitution replace it inside of the absolute value sign. So 2.5 plus 2 pi instead of the integral symbol. Now fortunately, we know enough about how absolute values work to simply say, well, the absolute value of 2.5 plus 2 pi, that's a positive number, and the absolute value of a positive number must be positive, so I guess the answer is 2.5 plus 2 pi. And you might then think, is that right? Is that all they wanted us to do? And actually, that is all they wanted us to do in that problem. If you're wondering why the absolute value had anything to do with the area, it's probably not very obvious. The absolute value is almost a non-factor here. So perhaps looking at another question like letter S will shed some light on it. In question letter S, you'll notice that the absolute value is no longer surrounding the entire problem. It's just surrounding the f of t. And that is where things get a little bit more theoretical. What they're actually saying in this problem sort of goes back to the conversation that we were having in the previous video about that theory behind the area and its representation, what f of t means and what dt means in the context of area. As a reminder, dt is the base of whatever geometric shape that you're finding, and f of t is the height of whatever geometric shape you're finding, figuring that f of t times dt is base times height, and that this integral is the sum of all of those base times heights, all of those areas. So think about the fact that the absolute value is surrounding the f of t. It's surrounding the part that we call the height. If you think about that, that means that all the heights, no matter what, are going to come out positive. Think about that then in the context of the picture, and think about what would happen in every shape if the height was positive. Now for some of these shapes, it's not going to matter. Like if I'm looking at this shape here that I highlighted pink, the shape that goes from -2 to -1, its height was already positive. And I know that its area is a positive 5 if I'm going positive base, positive height. But then you think about a shape like this one, this little teeny yellow triangle here. It has a negative height. And this absolute value symbol is saying, no, 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 make it positive. So let's focus for a second. That was me being a little bit theoretical, but let's focus. We want the integral from 0 to 10. We want all the areas from 0 to 10. So I'm just going to focus on those integrals or areas from 0 to 10. And I'm going to interpret this to say all of the heights have to be positive. Now when I wrote all my calculations, these were just all the areas themselves, and I didn't write positive or negative, because remember that depends on the direction in each problem, and that can change. So I'm just going to keep these numbers in mind, but I'm going to recalculate in my head using the signs of the numbers. Remember, I'm going from 0 towards 10. So by definition, the base is going to be positive. But let's think about this first yellow shape. Positive base, positive 1, positive height, yep, its area is still positive 2. Then I'm going to think about this green shape next. Positive base, positive 2, positive height, base times height, positive times positive would be positive. Okay, so its area is still positive. Got it. Now in this pink shape, positive base, because remember I'm going to the right, negative height, wait, no. This says positive height. Remember in letter S it said make the heights positive? So what if the height of this was a positive value? I'd have a positive 3 for the base and a positive height for the 1. So when I do positive times positive divided by 2, that's going to give me a positive area of 1.5. Interesting. Okay. Now I'll do the blue shape. That's the one from 6 to 10. Positive base. I know we don't really think about circles as having a base, but bear with me here. Positive base going to the right. Positive height, because the circle goes up. Positive times positive is already positive, so 2 pi is still a positive area. So now if the integral in letter S means find the sum of all the individual areas we came up with, the sum of 2 plus 2 plus 1.5 plus 2 pi really can't be added super cleanly, so I'll do the best I can and just call it 5.5 plus 2 pi. I'm not actually going to bother trying to figure out what that is. You can leave answers like this without simplifying them. That's totally fine. So the interesting effect then of the absolute value sign means that it made the height of each individual shape positive. And that does impact some of these little ones that seem to be underground. It's essentially like saying, no, reflect them up, if you want to think of it that way. Now, as you're looking at each subsequent problem, you might want to ask yourself the difference between having the absolute value around the whole thing versus having the absolute value around just one specific dimension of your geometric figure. For example, question letter U again has the absolute value symbol around just one dimension of the shape. And there's also a 2 next to that one dimension. So that one's kind of interesting. Let's look at that one, figuring that it's probably similar to letter S that we just discussed. In this one, it's kind of implying that, again, just based on the way we understand these terms, dt is kind of still our bases, f of t is still our heights. So let's think about what's happening. The base is still going to do what the base is going to do. That doesn't seem to be a big deal. But the heights, 2 things are happening. We're doubling the heights and making them positive. And then we have to find the entire integral from 10 to negative 4 and add them all up. That's a lot of work. But let's see if we can at least give it a go. The good news is we've done a lot of these areas already. Hopefully, we can simply make some small adjustments to deal with the fact that we now need to, and I'll make a little note of this to myself, double the heights, and we need to make them positive. So double the height and absolute value. Just something to keep in mind there as I go through each shape. Also, I'm starting at 10 and ending at negative 4. Remember, the integral is from 10 to negative 4. So that's a lot to have to keep in mind, but I just want to make sure that we're at least thinking about those details. So let's start at 10. We'll go backwards to the left, and we'll double the height, make them positive all the way through. Let's think about that first shape, the semicircle. The semicircle is going to be, and this is where we have to just make sure that we're thinking about this here, double the height. Now, it's a little tricky to think about semicircles as having a base and a height. So if you want to think of the height as 2 pi, or 2, sorry, that might make a little sense. If you want to think of the base as 4, you can be a little bit liberal with this if you want to. But here's the moral of the story. If I'm doubling the radius of this semicircle to make the height of it go all the way up here, then its new radius is definitely going to be 4. And if I think about that logically then, that certainly is going to make this shape a lot taller than it was. So, thinking about that shape then, it becomes a weird little elliptical thing because the radius horizontally isn't changing, the vertical is changing. Let's just keep things simple. let's assume we're going to take this region and multiply it by 2. We're doubling it. So if the area was 2 pi before, now it's going to be 4 pi because I'm stretching it out like that. But remember this direction thing? I'm starting at 10 and going towards -4. I'm going to the left. So even though I'm doubling the height of this circle, I'm also going to have to deal with the fact that it's negative, because I'm now going backwards. Negative base, positive height is going to give me a negative area. So that semicircle is definitely going to have an area of -4 pi. All that to say, double the height just means double what you have. Double the area, if you want to think of it in those terms. But pay attention to that absolute value. Pay attention to that direction. Lots of little things. Now, next region, I need to double the height and I need to go backwards. Lots to digest, so let's take that into account. First, I need to double the height. The height was 1, now it's 2. Do a little bit of side work here. Now, I need to go left, so from 6 towards -3, that's a base of -3 divided by 2. 2 times -3 divided by 2, now the region's -3. And if you're looking at this going, okay, Herbert, you're making this way too hard. Just double all the freaking areas. You can totally do that. I mean, honestly, that's what's going to happen anyway. If you're doing base times height times 2, that's the same thing as just doing base times height first, and then times 2. Where you times the 2, whether you times it to the height or the whole area, doesn't really matter. So let's make our lives a little bit simpler then. If I'm doing this green triangle has a base, now a positive height. So its area was 2, double it, 4, -4, because I'm going backwards. The yellow one next, I am going from right to left, so negative times positive gives me a negative area, -2. Next shape, negative, oops, forgot to double, -4. So many things to juggle. Double, make it negative. Let's just go with that. Double, make it negative. Double, make it negative, next one would be -6. Double, make it negative, next one would be -10. Double, make it negative, next one would be -6. And double, make it negative. Be careful here just to make sure that we're thinking about it, because this one is also underground. If I double the value, I'll have 1. That's for sure. But let me think about the sign. Negative base, positive height, because remember that's what was happening with the absolute value, positive height. Negative base, positive height is going to give me negative area. So, thinking on this for a second, we've got a lot to have to digest here, but this area is the sum of all of these individual pieces. So if I just kind of start clumping things together, it's like I have 17, 27, 28, 34, -34 minus 4 pi must be the total area of all of those individual pieces added together. Thus, -34 plus 4 pi, sorry, -34 minus 4 pi must be the value of my antiderivative. It's a little tedious, not gonna lie. It's not something that I would say, oh, see, wasn't that easy? I mean, it takes time. You have to think about those things. You could tell. I got tripped up a couple of times because there were so many things to juggle it. Double it, absolute value, and add it, and go backwards. Lots to think about. But if what you're doing makes sense, then hopefully you can keep those thoughts straight. Even though they might be a little bit tedious, hopefully they still at least make sense. Why we're doing them can hopefully be more important than, oh my gosh, this is going to take forever. Now, of course, I'll leave question letter T as kind of an exercise for you, if possible, because that one's pretty similar to letter R. And hintity hint, if you've already done the integral from -4 to 10, and the absolute value is on the outside of the expression, you probably don't have to do a whole lot in order to figure out the answer to letter T. I'll also give you some time, if you haven't yet, to chew on the difference between letter R and letter S, what the effect of having an absolute value outside the whole expression is versus having an absolute value around just one specific part of the expression. It's not an important question to articulate the difference. I've never seen on a test or even on an AP test that they would ask you to actually write something for something like this. It's just more of an observation, just something to think about if you can. Before you go on to the next video though, just make sense of everything, make sure these absolute value things made sense, and of course in the bigger scheme of things, make sure that the overall concept of finding an area using direction and the physical size of the shape makes sense. The last video is going to walk you through question number 7, and then we're going to kind of put this idea to rest for now. The next page, page 4, consists of another problem much like this one, but I think it's kind of overload to do a lot of these at once, so just kind of tread carefully. If you feel like you're up for a challenge and you actually don't want to bust your momentum, you actually might want to kind of look ahead, jump over to question number 4 and try that one if you feel like you've gotten some momentum going and you want to just keep going. If not, I fully intend on page 4 being kind of a separate day. I'm going to list that actually on the learning plan as Friday's task. So don't push yourself. Think about what's best for you and think about what you need to do between now and the time you start your next video. If it's best for you to just kind of let this idea marinate for some time, then finish it, check your answers, and be prepared to do one last little thing on question number 7. If you want more practice, if you feel like you need more practice, then skip ahead, watch the next playlist, because remember it'll be a whole separate series of videos, and feel free to start page 4 if you want another problem much like this one to try. Use your best judgment, decide where to go from here, decide what suits you best.